Here's problem 212. A rock is thrown downward from an unknown height above the ground with an initial speed of 10 meters per second. It strikes the ground 3 seconds later. Determine the initial height of the rock above the ground. Alright, so we're above the ground. We're going to throw a rock. We're at some height which we don't know. What we do know is that we've thrown it with an initial velocity of 10 meters per second. And because we're going to select our initial velocity direction as positive, then down will be positive. So our initial velocity and any other velocity going down will be positive. That also means that our acceleration due to gravity, which is always down, is going to be a positive 9.8 meters per second squared. This kind of makes sense because if we threw this ball down, it will start increasing in velocity, and that we could associate that with a positive acceleration. And the time it takes to reach the ground will be 3 seconds. We also will know that our displacement will be this total distance to the ground. Let's call it delta y. And in terms of magnitude, it's going to be the same as the height above the ground. So if we can find delta y, we would find the height above the ground. So we actually have 3 kinematic variables given and a fourth one asked for. We can do this. So let's look at this. We have displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. This is going to be equal to 10. Time is 3 seconds plus 1/2. Acceleration is 9.8. 3 seconds squared. And that gives us what? .1 meters. So our displacement delta y is 74.1 meters. That will have to be the same as our height above the ground, and hence that's our answer. That's the initial height of the rock above the ground. Straightforward as that. Just set up our kinematic equation and solve for the unknown.